without further ado, take it away, Paul.
Thank you very much, and thanks everybody for coming along today. I know I'm the thing that stands between you and lunch, which is never a fun place to be, but here I am. The presentation I'm going to talk to you about today is related to IoT scenarios, right? And in particular, what we refer to as edge computing. I'm going to talk to you a little bit about the role of edge computing, mostly as it relates to data, right? What are some of the challenges that emerge from dealing with data at scale outside of the cloud, and how does that relate to the use of cloud infrastructure for analytics against those data sets, and what do you do about some of those challenges? Most of what I'm going to talk about today is just fundamentals, right? I'm going to be talking about the underlying aspects of the differences that emerge between edge computing and cloud infrastructure that introduce challenges, right? And how do you go about addressing those? So those fundamentals will be built on kind of solid information about data trends, right? The growth of data, where does that arise? What form does it take? What capacity is available to deal with that data? And how do the differences in capacity in different environments impact the architectural choices that you make in building systems to work against those types of data sets? Right, so how do you overcome those capacity gaps? I want to make it practical. I'll talk about specific examples of IoT architectures. We have some visibility into that, so I'll bring some personal perspective on those things. Hopefully that's of some use. And leave you with some information about best practices or strategies you can apply if you're faced with these sorts of challenges. So hopefully, amongst the room, within this group, you've got some exposure to IoT environments, or you're working on these types of projects. If that's the case, we'd be pleased to talk to you more about it. I'll be here this afternoon, so happy to talk. All right, so let's start with just talking about edge computing, right? I'm sure you all have your own ideas about what that means. What I want to talk about, of course, is the definition of it that I'll be using today. Right? We're going to talk about this in terms of data. Right? IoT, or Internet of Things growth, is beyond a doubt the fastest generator of new information in the world today. Right? The types of devices that exist outside of the cloud are generating massive volumes of data. This is some information about that rate of data growth. Estimates within 3 years of about 80 zettabytes of information being generated at the edge of the network. Compound annual growth rates of about 20%, a little bit less than that. Significant data volumes. Now that's fine, right? Everybody knows, right? More data up and to the right, right? Lots of data being generated in all environments. But the interesting thing about that from the perspective of edge computing is that the edge, of course, to get access to that information and use it in a consolidated analytics infrastructure that you're likely to have operating in the cloud, you need to get that data to that analytics infrastructure. You need to store it. You need to process it, analyze it somewhere. Now, if you look at the volume of data being generated at the edge today and the volume of data likely to be generated tomorrow, and compare that to the capacity available in the internet as a whole to deal with that volume of information, there's a significant gap. This is the kind of detailed global forecast information on interconnect capacity, so worldwide bandwidth available across all types of networks, broken down by different types of providers of that infrastructure. If you look closely at the second little bar chart there and the second column along, that represents cloud provider capacity for interconnect. Right? Today, across all of the major public clouds, they're just shy of about 2,000 terabits a second of interconnect capacity for communication into and out of the cloud environments. Right? 2,000 terabits a second. Here's the graph, right? Capacity today, volume of IoT data being generated today, right? An obvious discrepancy there, right? So this is the fundamentals, right? The gap between what's being generated at the edge and what capacity is available to bring those data sets into the cloud, right? Fundamental. So what's driving that? Bad pun, I know. Here's an example of what a modern edge device looks like. right? This is an autonomous vehicle from GM Cruise. More than 40 sensors in this car. They're driving about 2,000 miles now every year. Significant volumes of data being generated out of edge computing environments. So think more LiDAR and less light bulb when you're thinking about sensors at the edge. Right? The volume of information generated from modern systems, perhaps things like MRI machines in the health sciences industry, or even what you all carry around in your pocket today, right? Your iPhone, your Android device. The applications and systems and sensors on these are generating vast volumes of data. So whether you're in health sciences, in automotive, in financial services, in telecommunications, the rate at which data volumes are growing is a product not just of the proliferation of these devices, but the sophistication of them increasing. Right? Now, that sophistication, of course, offers opportunities for work to be done against data at the edge. Right? The distribution of machine learning models out there to automate processes at the edge is obviously important, but the build of those models, right, the generation of the feature sets, the analytics performed against them to drive the business outcomes required, mandates the need for centralized processing against aggregated data sets from the edge. So what do you do about this? Right? There's an obvious gap between the volume of data being created and captured and copied, consumed, and the rate at which that's increasing. Right? We need to solve this challenge. It's a fundamental challenge. Now, the cloud providers, of course, are scaling out their systems to accommodate this, building more and more capacity over time. Here's a quick map of global cloud data center and on-ramp locations as of first quarter or last year. It's changed a lot since then. But this is a distributed environment, right? Networking is fundamental to how you scale systems to deal with large volumes of data. Now, that's not going to solve all the problems, right? The rate at which interconnect capacity is growing is trailing behind the rate at which data are being generated at the edge. So this is the core of what I want to present about today, this notion of edge to cloud, the difference between these environments, the strategies that you can apply and think about for bridging that gap and what you need to do. So, in simple terms, what needs to happen and what does happen for these types of systems, when you think about it on the left, our edge computing environment consisting of the sensors, IoT devices, and other generators of information, right? Increasingly sophisticated, increasingly numerous, require you to capture data from them at the edge, right? You can't stream it across the cloud to a central location at the outset. It's just not physically possible and never will be. In fact, that gap is getting larger. So it requires storage at the edge, right? We are storing data at the edge of these environments, whether it's from a turbine on a jet, or the sensor devices in a car, your iPhone, storage exists at the edge. Those data acquisition systems hold that information, perhaps for computing performed against that at the edge to drive the outcomes from models deployed there, but also in order to facilitate the filtering, aggregation, and processing that information to make it possible, make it feasible to transfer what's required to the centralized analysis systems typically held in the cloud. Right? And that's the role of the edge to cloud topic of my presentation. What happens between the edge, where you capture that data, hold it in storage, and the cloud environments that need to be used to gain business value from the rich data sets at the edge. That's the role of what we call edge to cloud. Right? Real-time applications with low latency requirements are going to be running on the edge computing environment. Big data applications for the advanced analytics, the machine learning, the AI are best performed in the cloud. So edge to cloud deals with how you move data at scale from edge computing systems to the cloud environment. Right? There is a lot that comes into that. It's not a simple challenge. Right? The types of problems that emerge with data at scale are inherently different to the types of problems that you would deal with for small-scale data. Copying small-scale data sets is straightforward. Transferring or copying large-scale data sets is not straightforward. But the reasons for doing it, right? Why do you want to do this in the first place? Right? We're all familiar with these sorts of things. Right? I'm preaching to the choir here, I'm sure, but whether you're increasing the efficiency of business operations or you're productivity of production capacity, removing the cost associated with maintaining environments, predictive maintenance on connected assets, very important in the manufacturing industry, simply understanding how these systems are being used to drive customer outcomes, right, customer experience, or potentially creating new business models, right, which is one of the things I'll come back to. We'll talk about examples of that. There's lots of good reasons for leveraging IoT data sets. They're numerous, they'll grow. You'll come up with your own good ideas about it as well. But it's that final one, the notion of creating new business models out of the data available from the edge, that I want to give an example of now. So one of the customers that WANdisco works with is an automotive parts manufacturer and supplier in Europe. Think about the sophisticated types of things that go into automotive manufacturing today, less so the less sophisticated things. But what they have done over time is build a range of automotive components that generate vast volumes of data, including the types of radar and LiDAR systems, the sensor devices, the hardware-in-the-loop infrastructure that sits in vehicles today. Any modern car you buy, depending on supply chain constraints, is going to be peppered with these types of sensors, and that's going to increase over time. So they are the provider of this type of physical infrastructure. Their data volumes are significant and a huge challenge. So what they aim to do, or aimed to do, and are doing now, is migrating on a continuous basis about 30 petabytes of data from their edge computing systems to the cloud every 2 weeks. Right, so 30 petabytes every 2 weeks within a 10 business day period, a significant volume of data, right? Essentially what, as far as I'm aware, is the largest ever continuous IoT data movement from edge to cloud, right? It's in the automotive sector, strangely enough. The approach they took to do that is indicative of some of the strategies that apply in dealing with these sorts of systems at scale. Mostly you want to do as little work as possible in large-scale systems, and you want to distribute that work as much as possible in order to scale effectively. Doing as little work as possible means not interpreting the data in transit, right? Treating the data at the edge essentially as files held in file storage at the edge, right? Which is what the sensor devices generate, capture through the data acquisition systems there. That file information in its movement to the cloud needs to be automated, needs to be scalable. And for this particular customer of WANdisco's, they also had a requirement around flexibility in the movement of that data. They didn't want to be beholden to a single cloud provider's cost structure over time. It's a significant strategic decision for them as an organization to make this shift from their primary revenue stream being driven out of parts that they sell to the actual primary revenue stream being generated from the information produced by those components. Right? So a significant strategic shift for the business, wholly reliant on the ability to move data at scale into cloud environments where, yes, they have their choice of analytics services, their choice of strategies about what to do with the information, but it's getting the data there that is the most significant initial challenge for them. Doing that with ease of access, with the type of capacity to scale, and with the flexibility and the performance required was really important for them. I fully expect we'll see that replicated across many different customers, many different industries. We see it already today in telecommunications, in health services, in financial services as well. And these are not the traditional places where you'd think about IoT and edge computing scenarios, but they are emerging. So those best practices, the ones around automation, scalability and flexibility, I'll explain a little bit about how WANdisco approaches these things, of course, right? Here to represent WANdisco, so you'll hear about that. But the automation of the movement of IoT-generated data from the edge, essentially file data captured and held in acquisition systems there, with high performance, requires some sophistication in what you're doing, right? You need deep knowledge about the manner in which the target environments for cloud storage and the subsequent processing stages and data pipelines there operate, how they scale effectively. WANdisco's done a lot of work with all of the major cloud providers to make that possible. We embed our technology in Azure's infrastructure. We've done joint engineering work with Microsoft around enabling the use of WANdisco's technology to support large-scale migration of data to Azure. We've done similar things with Oracle, with AWS, with Google, with Alibaba, all of the significant cloud providers. And we're working with them around changes to the way their storage systems operate to make feasible some of the problems that occur, again, at scale. One of the things that you might not consider, but that you need to think about in edge-to-cloud scenarios is how do you validate that the data you generated are the data that you've made available in the cloud? That may sound like a simple thing. Well, I just check, does the content look the same? It's difficult to check that when you've got 30 petabytes of new data every 2 weeks, right? You can't even list the files associated with that content in an efficient way. The scale problems that emerge there are very challenging. So working with the cloud vendors to optimize mechanisms for end-to-end file integrity checks, end-to-end content validation is part of what WANdisco is doing. The scalability of these solutions as well, the ability to horizontally scale data transfer to take into account the resources available and consume and use those in a controlled manner to the best extent is hugely important. So I'll explain a little bit about that. And then lastly, the flexibility, right? The need, of course, to migrate large volumes of data to the cloud is serviced to some degree by each of the cloud service providers. AWS, Azure, Google will all offer you technologies for bringing data into their cloud environment. They won't offer good technologies for bringing data into their competitors' environments, of course. So there's a need for some more flexible technologies to accommodate that. So automation. This is, in fact, a quick snapshot of one of the views that WANdisco's technology provides, just to give you an idea about the manner in which our products support automating the transfer of data sets at scale. A lot of what comes down in the important parts of automation is the simplicity of managing those environments. By federating and delegating control of how data are moved, where your sources are, where your targets are, monitoring the progress of those transfers over time. All of those aspects support automation. So you need to bring that forward in the tooling that people have access to in order to accommodate these large-scale data transfers. So when we're talking about petabyte scale or beyond data transfers from complex distributed edge systems, automation is key to that. Now, whether you automate that through user interfaces or through scripting or through APIs, those facilities all need to be available in order to bring those systems into whatever architecture you've got in place already or the architectures that you want to build. So automation's key. Obviously, scalability is important. Every system, of course, has its boundaries, right? Nothing is infinite. Large-scale data transfer technologies need to help you understand, accommodate, and manage the limitations that are inherent in the end-to-end flow of data. Not just the system that's performing that task, but the target environments, the source systems, the bandwidth, how that changes over time. All of that needs to be managed and visible to users to help you accommodate the limitations that are inherent in these systems. So again, the scalability may be a slightly more nuanced thing than you would expect from the outset, but visibility into those limitations, the ability to define and manage policies that control how much of your resources are being used, to visualize that, to track it over time, and to integrate it with other systems is hugely important. A good example of that, we have a customer, large US telco, using WANdisco's technology to migrate some of their on-premises data sets, not edge computing information, unless you look at it in the right way. It's called data records, generated from mobile phones, of course, but held in their on-premises systems, into Amazon Web Services. So we're talking here about 10 petabytes worth of data, again, on a continuous basis being moved into those environments. Because they're a telco provider, they have access to some unique capabilities in terms of bandwidth in their infrastructure. They can provision bandwidth, they can plan for that, they can calendar ahead of time expected demands on their network that they can use to orchestrate policies that apply in WANdisco's technology to optimize how much of that available bandwidth is being used and to accommodate the future changes in that bandwidth over time. So unique aspects of what you can do and need to do at large scale. So that scalability is important. Flexibility as well. Understanding the impact of decisions that you make up front in building large-scale systems is critical. It's easy to make decisions. It's easy to make decisions regardless of whether they are easily reversible or not so easily reversible. Sometimes it's difficult to understand which is which. You need to have a good understanding of the impact of those upfront architecture decisions to avoid lock-in, to avoid introducing limitations that are going to impose significant cost for you down the road. So take advantage of the expertise of systems integrators, of perhaps vendors who have some familiarity in these areas to avoid making poor decisions that lock you into the wrong approach. The most simple example of that, of course, is the choice of target environment in large-scale migration. Don't lock yourself in to a cloud vendor's individual environment just because that met a business need up front. Right? That's not a good decision. So, I think I'm ahead of time. I haven't had the hook around my neck yet. Quick summary then, and of course,
the hook is not yet.
Yeah, happy to take questions. I think we left some time for that. Firstly, IoT environments, whether you like it or not, are going to form a part of your future. They are where the majority of new data will be generated. If you don't think of them as sensor networks, if you don't think of them as edge computing environments, you're probably thinking about them in the wrong way. You need to understand what's unique about those sorts of systems. The reason you need to do that is because organizationally, businesses will gain huge value by leveraging that data effectively, whether that's driving new business models, the example being our automotive parts supplier, literally modifying the entire revenue basis for their business on the back of edge computing data, or whether it's because of the need to optimize customer experiences, like my telco example, bringing call data records at massive scale to cloud environments for better analysis. Whatever it is, your futures will involve edge computing and IoT/sensor data. That's it. WANdisco provides technologies to help with some of this. Other vendors do as well. Look around, but have a clear understanding of some of the challenges. They're not always obvious. The sorts of problems that emerge at scale are different, fundamentally different to the problems you'll encounter for smaller scale information systems. Try and understand those well. Hopefully this is a little taste of that. And of course, you can talk to WANdisco about how to overcome some of those challenges. We've worked with many organizations to do just that. Our technologies, which is kind of what I'm in charge of, very specifically targeting these sorts of solutions. And yeah, I'd be happy to share my experiences with how we've done that for others as well. So thank you very much for coming. Lunch awaits, I'm sure, at some point, and I haven't kept you from it too much, so thanks again.
Thank you, Paul. Okay, we have plenty of time for questions, so if anyone does want a question, and looks like there is a question. Would you like the mic, sir, or?
No, that's all right.
I'm so pleased. Right, far away.
No. WANdisco basically provides, you don't deal with IoT devices, you deal with the data that is generated by the IoT devices. Is that correct?
Correct, yeah. When you think about IoT systems, the typical thought that crosses people's minds is streaming data from those sensors to some other environment. There's great technologies for that. That is not what WANdisco does. Right? We do not deal with streaming data directly from sensor devices into other environments. We deal specifically, if I can go back to my slide, which was the appropriate one. I can't find it. Right. This is the best picture that describes that difference, and it's important to understand. So from edge computing environments where sensor networks exist, small-scale systems, large-scale systems, whatever, they're not all just streaming data to the cloud, right? Your light bulbs maybe, right? But your LiDARs on the automotive vehicles are not, your MRI machines are not, your telco, mobile phone, cellular network infrastructure is not streaming all of that information directly to some target. There are points of collection at the edge where data are held in very simple forms, relatively speaking, that still require the type of large-scale transfer, movement, management, orchestration in order to be dealt with appropriately. That's where WANdisco sits, not directly against sensor devices. Right? We don't have embedded systems, capabilities, or technologies. We deal with the type of data volumes that are resident typically in file or object-based storage, mostly in distributed systems, but we deal with standard SAN-based environments as well. The automotive example was just NetApp instances held in a variety of locations at the edge, but at very large scale, cycling through new data on a very frequent basis. They don't have the capacity to scale up their storage at the edge in order to maintain the ingest of all of that data. They need to shuffle it off very frequently, right? They collect it at the edge. WANdisco is involved in helping shuffle that data from the edge to the target environment and in orchestrating the data pipelines that surround that as well. So we have knowledge, of course, when data move, because we move it, and we can use that knowledge to initiate the work required to trigger or perform subsequent data pipeline processing in the cloud. So one of the things that we do there, taking those data formats at the edge and automating the use of analytic platforms in the cloud, platforms like Databricks and Snowflake and BigQuery and others, in order to transform that data into the form that makes it immediately useful and usable in that target environment. The form it's collected in the edge is not always how it needs to be in order to be processed in the cloud. So we deal not with the sensor networks directly, we deal with the data that they generate, we deal with the transfer and transformation of those data sets at massive scale. More questions?
So one of your slides, some of your slides talked about the big gap between cloud capacity and the amount of information generated. And I get that WAN is something about optimizing some of those problems. But overall, what do you see in the future as the solutions have capacity problem? And is it frequent capacity or storage capacity?
Yeah, well, those slides I was showing before, let me find that one again. So I think, where are we? So this slide here talks to, on the left-hand side, that is total bandwidth capacity into cloud service providers. It's a bad slide. I haven't even got labels on my axes, right? That's terrible. What sort of CTO am I? That's terabits per second of interconnect capacity into cloud service providers as of 2022. So think of that as the total bandwidth available across your major public cloud providers. Just shy of 2,000 terabits a second. And of course, that's being used for a variety of things, right? It's not just edge data being pumped across that network. That's everything that the cloud providers are doing in terms of ingest and egress of their data sets. The bar on the right-hand side is the current estimate of IoT-generated data globally, right? And it's just a quick indication of that huge discrepancy between the volume of data being generated from these sorts of systems and the capacity of our cloud infrastructure to accommodate those data volumes. And really what it means is that you have to do something else with that data than just send it to a cloud, right? You have to. The simplest thing to do, store, filter, or process that data only at the edge, right? Now, processing the data just at the edge is great for some use cases, but you have to determine what those use cases are for and plan and implement and perform those. Then you can throw away the data, right? You forget about it. Much of the data, though, like is the case with all things big data, you don't know the value of your data tomorrow, right? This is why cheap storage and cheap infrastructure to archive data has been so successful, right? Businesses recognize that it's almost cheaper for them not to filter their data and store it than it is to even determine what they want to get rid of. So that, in combination with the fact that the future value of data may be more significant than they recognize today, drives the need for additional storage around these data sets. But the fundamentals, right, this is real data, this is the reality of the world, means that it's simply not going to be possible to store all of that information. So choices need to be made about what to do with it. That's where the challenge lies, right? We all need answers to that. All right, a few more questions down the back.
I have a philosophical question
Oh,
that
okay,
might be a little provocative.
great.
So,
That is a big question. So organizations dealing with data are, of course, in need of thinking about the bigger picture at all times, right? Well, whether they're dealing with data or not. Organizations should be thinking about the bigger picture. Part of the benefit that comes from having access to large volumes of information is that there may well be real, human impacting value in those data sets. I'll come back to my automotive example, right? The type of data being generated from these devices will literally have an impact on the ability for traffic to be safer or less safe in the future, right? It will literally save or not lives, right? The value behind that data. It seems, it's a little, there's a few steps in between, of course, but the reality is that the information holds vast value, right? Human impacting value. Health sciences, of course, the same thing, but every industry has the capacity to do good with that data, and we don't always understand yet the value inherent in those data sets, but the assumption has been that the value is there and that organizations have been willing to trade off the costs associated with consuming, so generating, consuming, storing that information in anticipation of that value. Now, of course, as organizations, they're going to be driven by profit motives and their own scope in the world, and that will be the primary driver for their initial uses of these things. But it's kind of instructive to step back from that very focused view on individual organizations at time and think about the larger value that emerges out of having access to information. When you think about the very earliest introduction of kind of big data techniques in health sciences as an example, right, going back to the bills of mortality being generated in the 1600s in the UK, prior to that, global health initiatives that require coordination and cooperation between organizations were very, very primitive, right? The introduction of data and useful ways of looking at that data, of standardizing it, of responding to it, have driven our ability to do things like respond effectively to the COVID pandemic, be prepared for future pandemics. So there's a lot of value in data, and it's not always obvious what that is. I personally would err on the side of saying that, well, I'm an optimist, right? I stand behind the value that is likely to emerge from data sets that we don't yet understand, and I believe strongly that there is huge value in assuming that, right? Doing what we can do today to capture information and either use it effectively or capture it in anticipation of using it effectively in the future. The downsides, of course, right, the costs of operating the sorts of infrastructure at scale need to be understood, and I know that across the public cloud service providers, they're all making huge initiatives and huge inroads into maintaining carbon neutral or carbon negative status. They've talked publicly about how they're either achieving that or will be achieving that in the future. So they have their eye on that as well. And I think it's one of the benefits, again, of kind of centralized models around large-scale infrastructure is the ability to drive those benefits at scale much more effectively than you can do in distributed systems, right? For me to run a data center, I can't readily do that myself in a carbon neutral way, but cloud service providers at their level of operation have the opportunity to do that. So hopefully I've kind of given a good rambling answer to your question rather than a bad rambling answer to your question. But those are the sorts of things I'd be thinking about. Mostly potential future value of data being unexpected, and yes, there are always good examples of those types of discoveries of information being more effective in the future. We should take that into account in making the sorts of decisions around those trade-offs, and there are always trade-offs in large-scale information systems. Okay, so over the left here, and then we'll kind of come back and hopefully not hold you up from lunch. We're still good, right?
Yeah,
Great.
8 minutes, so yeah.
Go ahead.
Hi, I'm Harish. I work at Verizon actually and sit familiar with some of the edge computing work they do.
Great.
So one question I have is, because we're not storing a lot of data on cloud and you will do a lot of processing on the edge,
Mm-hmm.
and as you pointed out, we lose out some of that precious data. Are there any applications out there or solutions out there, or what are the methods where
Okay. So I think the question comes from a strong position of understanding where those challenges are, because you've highlighted one of those areas where, as an industry, we're kind of challenged by the fact that the skill sets required to even identify or implement solutions that get value out of the data at the edge are increasingly in short supply. In fact, I heard last night, it's like in data science roles, there's 15 open roles for every practitioner in data science in the United States today, right? Huge over demand and under supply of the skill sets required to do that work. And in the end, it's the skill sets that are the huge bottleneck around exactly that challenge. Less so the systems and products and services that surround that, which we're, as an industry, building up over time. We'll continue to accumulate good insights and good practices around that. But a lot of that work is exploratory as well. I think you'd understand that much of what we do in data science is exploratory in nature. We're discovering new ways of approaching questions and answers about data, new techniques for doing that. The rise of large-scale ML models is bringing out interesting insights from data sets that we were previously unable to get good information or insights from, and that's going to continue. That type of progress will continue. But the bottlenecks around it are mostly in the skill sets and the ability to deliver and implement systems to do that. So the sorts of answers to that at a technology level, some of it will come from products, some of it will come within organizations like Verizon with great skill sets around that, other telcos in the US as well. Yeah, I would say skill sets are more of an issue than the products and technologies to adequately scale what needs to be done in edge computing environments. So if you can find the right people, hang on to them, don't let them go. They'll be very valuable and potentially a good competitive differentiator. So yeah, I think that's a poor answer again, less rambling, but hopefully that's of some use. All right, here.
You've made a nice case for why IoT is a strong application for this large-scale data transfer and orchestration.
Mm-hmm.
What I didn't get was whether there's anything specific that you did at WANDisco for IoT versus other similar applications. Do they need special compression given the nature of IoT devices, or is this just another example application for, are there any differences in the technology?
Today, few. What we've found, and let me give you some background here, WANDisco's technology emerged from the big data space. We were originally applying some very smart distributed consensus technology into Hadoop infrastructure to support its ability to scale beyond a single data center. Right? That's what WANDisco's role in life used to be. We went through a process of taking that technology and applying it to cloud migration use cases for organizations wanting to move off big data infrastructure they'd invested in on-premises and migrate to cloud environments without disrupting the operations of those systems. Now that was key to WANDisco's success with that technology, the ability to move data at scale without the need to change how you are generating or ingesting that data. Right? Just the applications and systems are even unaware that WANDisco's technology is involved, other than, of course, the overhead we impose because we're asking for more work to be done in moving data in addition to what was being done before. You can't avoid that.
And those applications typically is not latency sensitive.
That's right, yeah.
It is.
Exactly. So in the IoT world, latency is of some critical importance for some types of use of that information. Typically, the latency imperative applications are the ones that get pushed to the edge because you get close to your data in order to take advantage of the benefits of local access and the speed that you can do things. So the types of applications that are less reliant on latency as a driver for what they do are those more suited to the role that WANDisco plays in moving, changing data, always ingesting, always adding to, over time, at scale, into a cloud environment. So it's an application of the same technology we had in the big data market applied to edge computing environments. What we've had to change there is the ability to treat the type of storage systems used at the edge as a source for our technology, not just Hadoop and Spark environments, but the kind of edge acquisition system, so we've added those capabilities. And over time, we're adding additional capabilities around things like integration with network infrastructure for bandwidth calendaring, things like the interpretation of the form of data being held at the edge so that we can initiate the work required to trigger subsequent data pipelines. But we're not going to be targeting with our technology the sorts of use cases that are streaming-driven or event-driven for edge computing. There, I believe there are excellent solid technologies already available in numerous ways that we don't want to compete with. But we have a strong position around the types of problems that emerge with data at scale that does not rely on those latency-sensitive applications. But, well, yeah. The other thing to add there is that the way WANdisco's technology works is we can initiate and manage the continuous movement of data at scale. So the sorts of systems that you might previously have attempted to use batch-based approach for, I don't know, transfer once a week or end-of-month cycles for compressed, aggregated data sets, now becomes something you can address in a very different way by simply saying, well, we'll take the raw data as it lands, use a technology like WANdisco's to make that available somewhere else and do our processing analytics in that other place. So we open up some kind of mid-tier uses where it's in between low latency and then the kind of batch-oriented systems that sit beyond that. Great. All right. I think there's no more hands in the audience.
I think it's good, though I had noticed another hand over
I
here.
had raised my hand. I was going to
Okay.
ask about the perishable data, which you kind of just covered.
Kind of, yeah. Yeah.
Some of the edge compute functions that can process some of that. So some of this data being created at the edge can be processed, and not 100% of it needs to necessarily go to the cloud.
Yeah, of course, and it has to be, right? That graph, right? The difference there, that's perishable data. Or it's perished data, I should say. This is perished data. So yes, my goal with WANdisco essentially is provide the technology that makes it possible to get value out of that gap, right? Those additional volumes of data, which are significant, in fact, larger than the total volume you could ever pump into the cloud, has value within it, that technologies like WANdisco can activate and make it possible for people to get value out of that gap there, and that's the strategic view.
And regulatory conditions require some of that data to be maintained long term, right? So that helps drive some of your business.
It does, yeah. Our financial services customers, some of the drivers for them are very simple. It's regulatory requirements around maintaining those data sets. Other customers are driven...
Life sciences.
Yeah, life sciences, same thing. Yeah, absolutely. Good insight. Other customers driven more by the need to open up new revenue streams, right? They have, or they know they're generating data, they're not collecting it, they're not doing anything with it, or they're leaving that to their business partners to take advantage of when they could be doing the same. And that shift in the world where the value of data at scale is being recognised, mostly because we now have the systems capable of processing at that scale, open up these sorts of opportunities. So yeah, great business to be in. All right, thanks very much.
Yep. Thank you all. And feel free to continue the IoT conversations over lunch.